Imagine for a second that you're walking down a busy city street. Rush hour, people everywhere. But there's a twist. You're completely invisible,
Okay.
totally unseen. You can walk into any bank, any corporate boardroom, any secret meeting, and nobody knows you're there.
Sounds like the ultimate superpower. The fly on the wall.
It does, right. But here's the catch. Because you're invisible, nobody can verify who you are.
Huh.
You can't open a bank account, you can't sign a contract, you can't even get a library card, because you can't prove you exist without revealing absolutely everything about yourself.
It's the classic naked invisible man problem.
That's the one.
To prove you're there, you have to drop the cloak entirely.
And that vivid image, which actually comes from the technical papers we're looking at today, perfectly describes the transparency paradox.
Right.
And it is arguably the single biggest friction point stopping blockchain from actually, taking over the enterprise world.
Because right now, public blockchains are basically public squares.
Oh.
And that's great for transparency, but it's terrible for business strategy.
Exactly. If a business wants to use a public blockchain today, they have to plaster their medical records, their trade secrets, their HR salaries on a giant digital billboard.
Which is a non-starter.
Yeah.
I mean, you cannot run a serious business if your supply chain contracts are visible to your competitors.
The moment you sign them.
It just doesn't work.
Yeah.
Imagine Coke publishing its secret formula just to prove they made a batch of soda.
So today we are doing a deep dive into a potential solution for this paradox. We're looking at a stack of documents from the Midnight engineering team dated 2026. And this covers everything from a new operating system called Midnight OS to their core philosophy of rational privacy.
And I think the mission for this deep dive is
Yeah.
really specific. And the private requirements of the real world.
Okay, so let's start with that term, rational privacy. It almost sounds like a contradiction.
It does.
The black box.
The black box. In finance, secrecy often implies criminal intent or a total lack of accountability. It's the trust me bro model.
Which regulators absolutely hate.
For good reason. And then on the other end, you have total transparency.
The Bitcoin or Ethereum model.
Show everything to everyone, which, as we said, is
Choose who sees what.
precisely. It's the ability to reveal specific information to specific people for a specific purpose. And the core shift here, and this is really the key insight, is moving from a model of trust me with your data to verify the criteria without revealing the data.
Verify the criteria without revealing the data. That sounds great in a marketing deck, but how do you actually build that? The source material uses a really interesting analogy for the architecture. They call it the waterproof blanket.
I love this analogy because it perfectly illustrates why privacy fails on most existing chains. Think about a waterproof blanket. Its job is to keep you dry.
Sure.
But if there's even one single tear in that fabric, just a tiny pinhole, the user gets soaked.
So you can't just patch it. You can't just add a privacy layer on top of a transparent chain.
No, you cannot just add encryption to a blockchain like you'd bolt a spoiler onto a car.
Right.
If the base layer leaks metadata like who you're transacting with or what time you sent the money, the privacy is gone. It has to be baked in from the Genesis block.
So it has to be holistic.
Right. Privacy isn't a feature, it's the environment. And the Midnight architecture is built like a triangle. You have three corners that have to work together. Corner one is privacy, with zero knowledge proofs. Corner two is compliance for regulations. And corner three is abstraction, which is all about usability.
And if any one of those corners fail...
The blanket leaks. The user gets soaked.
You mentioned zero knowledge proofs, or ZKPs. We hear this term thrown around a lot, but the documents use a hospital example that makes it much clearer. They call the status quo the data dump.
Which is pretty accurate. Think about how you deal with a hospital today. Let's say you need to prove you have insurance, or that you don't have a specific allergy.
Okay.
To do that, you usually have to hand over your entire medical record. The hospital sees your history, your meds, your birth date, tons of unrelated private data.
It's total overreach. It's like handing over your unlocked phone just to show someone one photo and they start scrolling through your gallery.
That's a perfect comparison. You are exposing everything just to prove one single thing. The Midnight approach, using ZKPs, flips this.
How?
There's this concept of a data wallet. So let's say you need to prove you're over 50 years old for a certain treatment.
Okay, so I have my digital ID in this wallet.
Right. But instead of sending the file with your birth certificate to the hospital server, your device does a mathematical calculation locally. It checks the data you hold. Is user over 50? And if the answer is yes, it generates a cryptographic proof.
And you send the proof.
You send that proof to the hospital.
To the hospital.
Data never, ever left your device. It also minimizes liability for them. They can't leak data they never held.
Wow. That is a fundamental shift. Mathematical proof of truth replacing data exposure.
And that leads us directly into corner 2, smart compliance.
Well,
Because usually when you say privacy to a regulator, they hear money laundering.
that's the tension, right? If I can hide my data, how do you stop me from doing illegal things? Tokenizing assets like stocks or real estate means following the law.
And following the law traditionally means doxing yourself.
Yeah.
Usually you're sending your passport, your address, your bank statements to some centralized compliance officer. And you just hope they have good security.
And we've seen enough data breaches, from Equifax to T-Mobile, to know they usually don't.
So Midnight solves this with a ZK compliance layer. Think of it as a digital gate. The documents use accredited investor status as the prime example.
Okay.
To buy into certain high-risk investments, you have to prove you have a net worth over $1 million.
So currently, I'd have to email screenshots of my bank accounts to some stranger at a firm.
Yes, which is insane when you think about it. But with the ZK compliance layer, you connect your bank account to your local data wallet. The wallet verifies the balance, creates that proof,
The green check mark again.
and sends that proof to the investment firm. The counterparty knows, mathematically, that you are accredited, but they have no idea how much money you have or where it's stored.
So your bank balance stays off-chain, but the regulatory requirement is fully satisfied.
You satisfy the regulator, but you protect the user. That's a powerful combination. The engineers call this the great wasmification, but really it's just about fixing the user experience.
The source material is pretty savage about the current crypto UX. It compares it to a complex receipt that nobody wants to read. It lists things like select network ID 48322, gas limit 21,000, bridge asset via hop protocol. I mean,
Yeah.
my head hurts just saying that out loud.
It's engineering complexity dumped right on the user. It's bad design.
Totally.
So Midnight moves to intent-based systems.
Which they explain with the coffee shop analogy.
Right. When you go to a coffee shop, you state your intent. I want a latte. You don't tell the barista to grind 18 grams of beans and apply 9 bars of pressure.
No.
You state the what, and the system, the barista in the machine, handles the how.
So in Midnight, my intent is just send. Okay, you mentioned browser-based. This is where the tech gets really interesting for me. We're talking about heavy cryptography. Zero-knowledge proofs are not simple math. How are they running this in a standard web browser?
This is the engine section of the deep dive, and it's
Yeah.
fascinating how they make this heavy math lightweight. It's a 3-step engine. First, you have WASM, or WebAssembly.
Sandbox.
Yes, it lets complex apps run safely inside the browser, which is standard web tech now.
Yeah.
But then you need power. That's step 2.
Web GPU.
Exactly. It taps into your local device's hardware, your laptop or phone's graphics card, for instant encryption. But the real magic, the thing that makes this truly scalable, is step 3, folding.
The Nintendo emulator saves state analogies.
Yeah.
I have to say, this was my favorite part of the reading. It made a very complex idea click for me.
It's a brilliant comparison, isn't it? Imagine you're playing a long, complex video game. 50 hours in.
Yeah.
You don't leave the console running for weeks.
Right.
When you stop, you create a save state. You compress all your progress, your inventory, your location into a tiny file so you can resume later.
And Midnight does this with the blockchain history.
Essentially, in traditional blockchains, to verify the current state, you often have to recompute the entire history of transactions. It gets bloated and slow. Cryptographic folding takes a sit. It prevents data bloat and lets the system verify a long history instantly. That's what keeps it all lightweight enough to live in your browser tab.
That is
Blockchain cannot do everything. So they separate security from throughput.
the dual lane analogy.
Exactly. Imagine a highway. In the left lane, you have the ranking blocks. Think of this as the security guard. Its only job is to maintain consensus, order the blocks. It's lightweight, secure, but it doesn't carry much data.
Okay, so it moves at a steady pace and in the right lane.
That's the endorser blocks. This is the cargo truck. It carries massive containers of transaction data. And crucially, it has no consensus duties. It just hauls data.
So by splitting the jobs, the cargo truck can just floor it.
Correct. The result is they're achieving over 1,000 transactions per second. But, speed isn't the only thing. Resilience is arguably more important. What happens if this high-speed layer fails?
This is the telescope mechanism. I've visualized this like an old pirate telescope extended out.
Right. State A is the high-performance louse layer. But if that layer hits a bug or a network failure, the system doesn't crash. It collapses, like closing the telescope down to state B, the base protocol.
It slows down, but it keeps working.
It's graceful degradation. The document calls this the Shinkansen principle, after the Japanese bullet trains.
Priority number 1, survival. Number 2, speed.
Just like emergency braking. It might be annoying to stop, but it's better than derailment. And speaking of redundancy, we have to talk about client diversity.
The forest of nodes.
This is a lesson learned from the Shanghai DOS attacks on Ethereum years ago. The vulnerability is monoculture. If everyone runs the same client software and a bug is found,
The whole network freezes.
the whole network stops. So Midnight has diverse clients running simultaneously. You have the standard client in Haskell, Amaru in Rust, Dingo in Go, and implementations in C++.
So if a hacker finds a bug that crashes the Rust nodes,
Haskell and Go nodes just keep going. The forest survives even if one species of tree gets sick.
that is some serious defensive engineering. It sounds like they're preparing for war. But engineering is only half the battle. Who actually runs this thing? We've seen so many quote-unquote decentralized projects that are really just 3 guys in a basement with the admin keys.
The section on governance is titled From Cult to Constitution. It's about codifying power. They outline the Intersect Pentad 5 pillars that balance everything.
Let's run through them. We have IOG, the founding entity, the Cardano Foundation as stewards, Emergo, the commercial arm, Midnight itself, and then the community, or Intersect.
And that last one, the community, isn't just lip service. The source shares a specific story about proof of agency that I found really telling.
Oh, yeah.
The very first constitutional amendment for Midnight was not raised by the core developers in London or Colorado.
So who raised it?
A community member in Japan. They proposed to change, the community voted, and it passed.
That's a great detail. It proves the system functions independently of its founders.
It's the difference between a project that says it's decentralized and one that actually acts like it. But even with good governance, there's a future threat looming over all of this.
You're talking about the AI section. This part felt a bit like science fiction, but it's happening now.
AI versus code.
Yeah.
Yeah, the document paints a pretty stark picture. AI can now simulate billions of attacks per second. It can scour code bases to find zero-day exploits a human would never see.
So good enough code is going to get torn apart.
Eventually, yes. If you build your financial system on code that's just pretty good, an AI will eventually break it. The defense here is formal methods.
Which is verifying code as mathematical theorems.
Yes. Instead of just writing code and testing it, you prove that the code does what it says it does. And like the difference between building a bridge and hoping it holds versus calculating the physics to prove it cannot fall.
In a battle between speculation and verification.
Math wins.
It's the ultimate shield against the AI arms race.
It creates what they call invisible infrastructure. You stop worrying if the bridge will collapse and you just drive over it.
So what does this all mean for the listener? We've covered a lot of tech here, but the document wraps up with a shift in mindset from passenger to owner.
Think about the typical internet user today. You're a passenger. You're subject to price hikes. Your data gets stolen. Terms of service change overnight. You have no control.
And you're often paying for the ticket with your personal data.
Exactly. The shift Midnight proposes is to an owner mindset. You participate in governance. You own your data in that data wallet. You verify the rules.
There's a quote in the conclusion that really stuck with me. It's a play on the old Google motto.
The shift from "don't be evil," which is a corporate promise,
A promise that can be broken.
to "can't be evil," which is a mathematical constraint.
That is the crucial difference. One relies on a CDO's morality, the other relies on the laws of the universe.
And that's where the value is. When you have a system that can't be evil, you can build entirely new businesses on top of it. Things we haven't even thought of yet.
We started this deep dive with the naked invisible man, the idea that we had to choose between privacy and trust. Midnight seems to be saying we can have both.
We can have privacy because of the trust provided by the math.
I want to leave everyone with the final question posed by the engineering team in the source material. It's something to really chew on.
They ask, if your financial and personal data could be truly private but verifiable, what part of your life would you finally feel comfortable moving on-chain?
Would it be your medical records, your voting history, your entire business? It's a wild future to imagine.
It is, but for the first time, it feels like a rational one.
Rational privacy. There you have it. Thanks for taking this deep dive with us. Don't just trust us. Verify the criteria yourselves. Catch you next time.